Here's another example of solving a prisoner dilemma with pre-commitment. We have a problem that we've seen before. Here's a verbal description of it. And I've given you the strategic form. It's really big. But here we have the two players, Walmart and Target, and they're choosing, this guy's choosing rows, this one's choosing columns. It doesn't really matter the interpretation of these rows and columns. And here's the payoffs already computed. So I'm going to ask the question, where should they locate? So we're going to seek a dominance solution since they choose at the same time, June of next year. Are there mutual gains from cooperation? And if so, can they trust each other to cooperate? And if they can't, that is a prisoner dilemma. And we're seeking a solution. Can they cooperate by Walmart pre-committing to choosing first? And then if that works, great. Or can they solve this dilemma by having Target pre-commit to choosing first? So let's find out first if there's a problem. Where should the stores locate? Well, they're choosing simultaneously, so we're going to seek the dominant solution. We want to eliminate bad strategies. That's the method. A strategy could be bad if it's weakly dominated by something else, but it turns out none of the rows are weakly dominated by any other row, and none of the columns is weakly dominated by any other column. So that method is not helpful. We could try to find non-rationalizable rows. That is a row that's not a best response to any column. So let's consider this. For the first column, the best row would be this one, the 17. It's higher than any other row entry. If this column is chosen, you're going to want this row. If this column, you want that row. And if this column, you want that row. So each of these rows is a best response to some column, so they can all be rationalized. And finally, starting to get a little tense here, the only option we have left is to look for non-rationalizable columns. So if you think the first row is going to be chosen, you could rationalize picking this column. If you think this row, remember the column person gets the second numbers, you'd want that column. If this row, we'd want this column. And if that row, you'd want that column. So if you can remember it, you chose this column, this column, this column, or that column. You never chose that second column, so that can be scratched off. Now, after scratching off a column, rows are easier to eliminate. If you think this column is picked, you'd want this row. If this column, that row. If this column, that row. So it turns out you never want that second row. So we can get rid of that. Now, after you've gotten rid of that, if you've gotten rid of a row, it makes columns easier to get rid of. If you think the first row is going to be chosen, you'd want this column. You're just looking in columns at the second number. So the 7 is higher than the 6 and the 4. So you want this column. If you think this row is going to be chosen, you'd want that column. And if you think that row is going to be chosen, you want that column. You never want the first column. So we get rid of that first column. So we're making progress here. We got rid of another column, so now let's see if we can get rid of another row. If the row person thinks that this column is going to be picked, it'd want that row. And if this column is picked, it'd want that one. He would never want this third row, so we can get rid of that. Now we have left just a game with 4 cells in it. And we've just gotten rid of a row. So let's see if we can get rid of a column now. If you think the first row, you'd want that column. If you think this row, you'd want that column. Actually, it turns out this third column here is now dominant. We can scratch off this. Given that we know the third column it will be chosen, the other player will choose the first row. So we have our dominant solution. It is Walmart chooses the first row, which is Northridge, and Target chooses the third column, which is Brentwood. And that is the dominance solution. Now, are there mutual gains compared with this? You have to look at all the other cells and see if there's any cell that's better for both. and give yourself a little bit of time to do this. Notice that this is the only cell that's better for both. This is the cooperative agreement that would be better for both parties. Walmart picks Hollywood, Target picks Hollywood, and they end up with payoffs of 21 and 8. Walmart getting the 21, Target getting the 8. Can Walmart trust Target to cooperate? Suppose they get together and say, Walmart says, I'll pick Hollywood, and Target says, yeah, I'll pick Hollywood too. Would Target really do what they say they're going to do? If Walmart is believed to pick this row, Target would look at a 5, a 6, an 8, or a 9, and to be so tempted, he's going to give in to his temptation. He's going to cheat Walmart and pick this. He's going to break his deal. Target is not trustworthy. On the other hand, is Walmart trustworthy? If Walmart believed Target when Target says that I'm going to pick this column, what would Walmart do? If he does what he says he's going to do, he's going to get 21. If he picks any other row, he's going to get something worse. So Walmart will do what they say they're going to do. So Walmart can be trusted. The fact that Target cannot be trusted means we still have a prisoner dilemma. They can't just talk to each other and reach this agreement. But the fact that one of the two parties can be trusted makes it more likely that this dilemma can be solved with pre-commitment. So can the two cooperate by Walmart pre-committing to its choice first? Well, we'd have to find a rollback solution here. When Walmart chooses first, it considers each of its 4 options. It considers how the other person will respond, and then what do I get out of it? So if I choose the first row, the other person is going to respond with this column, leaving me with 15. If I choose this row, the other party will respond with this column because they get a 9 instead of these other payoffs, which are less. And that leaves me with 5. So I get 15 from this row, 5 from that row. Here, the column chosen would be this one, and that leaves me with a 7. And then here, the column chosen would be this one, which leaves me with another 7. So altogether, the best thing for me, thinking back on it, is that I pick the first row. The other person responds with this third column, and that gives me 15. So the rollback solution is Northridge Brentwood. And that's what happens if Walmart pre-commits. What we're seeking, though, is this cooperative result. So they cannot cooperate and solve their prisoner dilemma by having Walmart go first. That shouldn't come as too much of a surprise, since the untrustworthy one is the one that really should be going first. Can the two cooperate by Target choosing first? Well, if Target chooses first, we seek a rollback solution. Target considers its 4 choices. And for the rollback solution, when it considers the first column, it figures that Target would choose this row, leaving Target. It figures that Walmart would pick this row, leaving Target with 6. If Target picks this column, it figures that Walmart would respond with this row, leaving Target with 8. And then if Target picks this column, it figures that Walmart would pick this row, leaving Target with 7. And then if Target picks the last column, it figures that Walmart would respond with this choice, leaving Target with 5. So out of all of those, let's see, if you pick this column, this row, you'll get a 6. This column, this row, you get an 8. That's better than the 6. This column, this row leaves you with a 7. This column, this row leaves you with a 5. The best one is for you to pick that second column. They respond with the second row, and that is the cooperative solution. And so that solves the problem. Target going first will solve this prisoner dilemma.